Season 13, Forces in Motion, Physics in the Necrotic World, Episode 97, Protective Equipment. Welcome, strangers. Protective equipment. This increases the time taken for the badminton player to be hit by a shuttlecock. I mean, in India, my dad would buy me a shuttlecock made of feathers, which is pretty nice compared to a plastic shuttlecock. Then we would play badminton the way it's meant to be played. Outside, on plein air. I think that's a French phrase for it anyways. That was the life. I mean, in that society, with my aunt, we would just enjoy the sunshine. Yeah, that was holidays for me when I was a child. Well, it wasn't that often. It was like once every 2 years. Ugh. It's a shame. Anyways, actually, no. I mean, not even every 2 years. It was like every 5 years. Ugh. 5 years. Anyways, actually, no, I need something harder than a shuttlecock for this explanation. A basketball is not really going to cut it either, as it's the wrong type of ball. A cricket ball, yep, you know what, that'll work. A protective equipment increases the time taken for the player to be hit by a cricket ball. Hang on, technically round this ball, would that work too? Yeah, that would work too, right? Nah. Cricket ball is better. Right, so basically, Newton's second law is technically force is the rate of change of momentum over time. So its force is equal to mass multiplied by final velocity minus initial velocities, with the velocities being in brackets over the time. The force acting on the player will be smaller, so reduces in terms of injury risk. So less of a risk assessment issue there. Schools and clubs have to do risk assessments, and well, with protective equipment, they have less risks, so a shorter risk assessment, which is nice, right? Force being equal to mass multiplied by acceleration, mass times acceleration, is how we actually commonly remember Newton's second law. But this is actually derived from the force being the rate of change in momentum over time. Force is equal to kx, so force is equal to spring constant multiplied by spring extension. Spring constant is also called force constant or stiffness constant. Energy is equal to half Fx, so half of force multiplied by spring extension. So E is equal to half kx in brackets times x. So energy is equal to half kx times x, meaning we have now derived the third formula here. So energy is half kx squared, so energy is half of spring constant multiplied by spring extension squared. See you next time at Physics in the Necrotic World. This is your host, Rimona R out.